So our next section of one sample hypothesis testing is when we are dealing with proportions. So we are going to use a z-test in order to do our proportion. So we are going to use our variable z, and we're going to use inverse norm for critical value. But we are using a z because we're approximating a normal distribution as long as we are meeting our criteria, our conditions, that our sample size times our p hat and q hat, as long as they are both greater than or equal to 5, we can approximate a normal distribution. So our z formula for this section is p hat minus p divided by the square root of pq over n. So in order to go through those steps, again, our conditions that we have to check are that n times p and n times q are both greater than or equal to 5. Then we will write our hypothesis using our p instead of our mu. We will be given that level of significance, use inverse norm to find that critical value, make that sketch and mark that rejection region, use our standardized test statistic formula, and then we're going to make that decision either to reject or fail to reject, and then write our conclusion sentence. So here's our example. A researcher claims that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 100 adults, 41% say that they use passwords that are less secure because complicated ones are too hard to remember. At a level of significance of 0.01, is there enough evidence to support the researcher's claim? So the first thing we need to do is check our condition. N times p hat, make sure it is greater than or equal to 5, and n times q hat. Make sure that as well is greater than or equal to 5. So our sample size is given to us, 100. P hat is our sample proportion. So in this case, it is the 41%. P hat is 41%. So 100 times 41% gives us 41. It is greater than or equal to 5. So we're good there. Q hat, you can find by doing 1 minus p hat. So 1 minus 0.41 gives us 0.59 for q hat. So if we take our sample size 100 times our q hat, we get the number 59, which is also greater than or equal to 5. So in this case, we are using a z because of the fact that we have proportions. We have met our conditions of n times our p hat and n times q hat. They're both greater than or equal to 5. And we also have a random sample. Those are different conditions that we needed in order to use a z distribution here. Now, before I flip it to the next slide so we have some space, when it comes to writing our hypothesis, we said that we are claiming that we are less than 45%. So less than is going to be our claim for our problem with that 45%. We've already marked our sample proportion and our sample size. We also were given our alpha of 0.01. So when we write our hypothesis, we're going to use P because we're dealing with proportions. It was less than 45%. Make sure you switch it to a decimal. So our complement then is greater than or equal. Claim means which one of those two symbols matches the exact wording of our problem. So our claim is HA because of that less than symbol. And again, our alpha was 0.01. So if we make the sketch, our shading is always based on our HA, which in this case is less than, so that means left tail. We use inverse norms since this was a z distribution. So we're plugging in all of alpha because there's one tail. And we get a critical value of negative 2.3263. We keep it negative. We keep it negative because we have the left tail, and we can mark our rejection regions. If we end up in that shaded area, we will reject. And now we are ready to do our formula. P hat minus P over the square root of PQ over N. Our P hat, our sample P, was 41%. Make sure you switch it to a decimal, so the top should both be decimal values of those percents. On the bottom, we do use P and Q, so it's based off of our population P. So that's 0.45, and the Q to that is 0.55. So real quick, I'll do that off to the side. Find Q, we were doing 1 minus 0.45. That's where you get the 0.55. And our sample size was 100. Try to type that in all in one go. Hit enter and round off to 4 decimal places to get negative 0.8040. It is not in our shaded area, so we fail to reject. For our conclusion sentence, at blank percent level significance, we're going to plug in our alpha as a whole number. So at 1% level significance, they're blank enough evidence. We're going to put is not, because that's coming from our fail to reject. To blank the claim, our claim was HA, so we are going to put in here, we are going to support the claim. That, I'm going to put dot, dot, dot. This is where we tie back into our original problem. So we hop back. Our researcher claims that. We're going to go from less than all the way down to our period. So we would copy over there, less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. Again, that's plugging in your inequality symbol, the value from our hypothesis, whether it's a mean or proportion, and the context of the problem. There's so much goodness in that little bit that we copy over at the end of our conclusion sentence. Now, there's one other thing to make note of. Sometimes when you're doing these problems, you're not going to be given a percent right off the bat. You might be given something like a phrasing of 10 out of 15 people like goldfish. A phrase like that is giving you the pieces you need in order to make that sample proportion. So in a situation like that, 10 would have been your X, 15 is your N. So if you have to find your P hat, you are taking that as a proportion, 10 over 15, and then turning that into a decimal value. That's going to be your P hat value. So if you don't get it from the beginning as a percent, we'll be given the things in order to turn it into your P hat.